right, geometry, we are ready to begin topic 9. Topic 9.1 is polygons in the coordinate plane. You do need some graph paper and a calculator. So if you don't have that handy, please pause the video while you gather your supplies. All right, let's title the notes 9-1, polygons in the coordinate plane. Okay, so on these, you definitely need to make sure you recall the distance formula. Remember, for distance, it's like a squared plus b squared equals c squared. That's kind of how I remember it. And to find each piece, remember you take the x's and subtract them, and you take the y's and subtract them. It doesn't matter which one you do first, since it's addition. All right, for example 1, I want you to go ahead and graph a triangle that has points x, y, and z at the locations of 1, 2, 5, 8, and 8, 6. Now I'm going to work through this pretty quickly, so feel free to pause the video if I graph them too fast. Graph them as well so there's not a super awkward silence. All right, so what we want to do first is determine what type of triangle do we have. Do we have a right triangle? Maybe. Do we have isosceles? Maybe. Do we have equilateral? I don't think so. So in order to do this, what we should probably do is use the distance formula to find the lengths of all three. Now, I think I'm okay if you want to assume that this one is shorter and really just find the other two distances. So we need to find what xy is, and we need to find what xz is. So for xy, I'm going to go ahead and do 5 minus 1 squared and 8 minus 2 squared. And I have 16 plus 36. So I'm going to end up having to figure out what the square root of 52 is. Just going to leave it like that for right now. X to z. I end up with 7 squared plus 4 squared, so 49 plus 16, and I get the square root of 65. So I can see from there that it is clearly not going to be isosceles, because these aren't equal, and it's not going to be equilateral, because all three are not equal. So my only choice now is, could it be a right triangle, or maybe it's just scalene. Now the angle that I think is a right angle is up here. Remember, slopes of perpendiculars have to be negative reciprocals. So I'm going to figure out slope of xy. So I'm going to rise 1, 2, 3, 4, 5, 6 and run 1, 2, 3, 4. So that is 6 over 4, which reduces to 3 over 2. Now, I need this one, yz, to be negative 2/3 if it's going to be perpendicular. Down 2 over 3, yes, it is. And since it is, I have a right triangle. Okay, so it's a scalene right triangle. Now, what if I wanted to define the area? Let's call this 1b. So area of a triangle, remember, is length times width divided by 2, or base times height divided by 2. So I already know this length. Remember, the base and the height make a right angle. So I do need to go ahead and figure out yz, because yz is going to be the height. So this is going to be 3 squared or 9. This is going to be negative 2 squared or 4. So this is going to be the square root of 13. So the area is the base, that was xy. We found that out to be the square root of 52, multiplied by the height, which is the square root of 13, divided by 2. All right, so entering that into the calculator, the square root of 52. Make sure when you enter that you do go ahead and close the parentheses. If not, it's going to, I guess in this case it wouldn't matter. You could multiply them together. Let's do it both ways so that you can see. And then divide it by 2. Now since you can multiply everything together under the radical, you should have been able to go the square root of 52 times 13 and then take that part and divide it by 2. Notice that both ways you're going to get an answer of 13 for the area. All right, hopefully that makes sense. Let's do one that is going to be a quadrilateral. So for example 2, go ahead and graph the points A, B, C, and D, 4, 3, 1, 5. Oh goodness, I can't read my own writing. I think that's 7, 1. And then D is 6, 4. And actually, no, let's make that 7, 8. All right, go ahead and pause the video while you graph those 4 points. Now clearly it's not a rectangle or a square, but I'm thinking maybe it's a trapezoid. Remember, in order for ABCD to be a trapezoid, I need one pair of opposite sides to be parallel. So if I could get these two to be parallel, I would have a trapezoid. Remember, parallel lines have equal slopes. So let's figure out the slope of BC. It's up 3 and over 6. 3, 6 is a slope of 1/2. So I need my slope of AD to also be 1/2, up 1 over 2, and it is. Therefore, I have one pair of parallel sides, and I have a trapezoid. All right, let's do one more. All right, so for example 3, let's graph a quadrilateral RSTU with the following points. R is 1, 5, S is 2, 8, T is 8, 4, and U is 7, 1. And go ahead and pause the video while you graph those points. All right, now that I've graphed them, I make my best guess. It sure looks like it is a parallelogram to me. Maybe it's a rectangle. It's hard to tell if those are 90-degree angles in the corners. So let's first of all prove that it's a parallelogram. That's the first thing we need to do. If I know both sides that are opposite of each other are parallel, then I have a parallelogram. I could also measure to see if they were the same lengths. Slopes to me is a lot easier. So I'm going to figure out slope of RS, and that is up 3 over 1. And I'm going to figure out slope of UT, also up 3 over 1. So there's one pair of parallel sides. Let's check the others. From S to T, notice it's downhill, so it's a negative. 1, 2, 3, 4 down, and 1, 2, 3, 4, 5, 6. So that gives me a slope of negative 2/3. Now, if this last one, RU, is also negative 2/3, then I'm in business. Negative 2/3. Down 2 over 3, down 2 over 3, and it is. I have a parallelogram. Now, my next question is this parallelogram a rectangle? Well, if it is, then these have to be 90-degree angles, which means this slope and this slope have to be reciprocals of opposite sides. And you can see they're not. This one is 3. This one would have to be negative 3, and it's not. So this is just a parallelogram. Okay, that's it. You are going to be working in your textbooks today on page 390. We're going to look at problems 18 to 23. So basically on 18 to 23, it's just this little section here. It's already got graphs up here that you're just going to look at, determine whether you need to use distance or slope to answer those questions. All right, do a great job. Watch the answer video when you're done.